Hello there, good day. Welcome to today's session. For today, for today we're gonna be discussing about the stack algorithm. So to start with, let's create a class. Say the name of the class is, let's say, let's just create a test stack. Okay. So yeah, stack is actually a built-in data structure built-in linear data structure in Java. So later on, I'm gonna show you that it's actually under java.util package. So to start, we can have something like stack. Let's see, st is equal to new. Okay, stack. So it's under java.util package. So all we just need to do is yeah, so we'll have to mouse over this one, and it's going to import stack under java.util package. All right, that's it. So there you are, java.util that under stack. So we have actually other list algorithms right here. So aside from stack, there's actually a lot of built-in algorithms here. So this time we are actually instantiating a stack object here, which is named st. Okay, so we have here a default constructor. So I'm just gonna show you the methods that are built in under this stack algorithm. So we have actually a lot. So as you can see, you have here an add algorithm, but it's actually originally or originated from vector class. So it's a Boolean method where it actually returns true or false. So the same with other like here though, add with the index and then object element. It's actually in a vector because both stack and vector are actually, it's like they are just family. The same with array list and with linked list. Okay, the only that stack is actually focused on the basic operations, the like push. Okay, push is a method in stack where you can actually add or insert data to it. So it's originally the class of under the class that is implementing the method push is actually stack. You can actually see here, and like earlier, you have seen their vector. Okay, another one is we have also pop, that's under stack, and then we have here listed a lot of methods that are under stack, but it's actually inherited from its other list algorithms, which are vector, which is vector and array list. Okay, but this time this is not our yeah, so we'll try to do some uh, let's say we are going to push 5 st.pop. So basically when we talk about push, this would allow us to insert data or element to a stack. Okay, and then for st.pop is going to remove sorry, remove data or element from the stack. And then both push and pop is are going to do the removal and the addition at one end, which is called tap. So the only thing that is going to be affected in that particular object of our stack is always the tab. Okay, so we can actually display this one. Okay, so something like this. All right, when we get to run this one, you are able to remove the push the 4 which is inserted, so which we recently inserted. So we are going to insert or push more data. So we have here 6, we have 8, and we have 9. So as you keep on pushing or inserting value or elements to our stack, so we have here the first inserted is 4, 6, 8, and 9. Since stack is a last in first out algorithm, therefore the recent inserted is actually 9. This one is the value at the top. Therefore, when we get to call the pop, once it is invoked, the 9 will be deleted. Okay, so we can also try this one out. So there you are, 9 is actually deleted. All right, so what else do we have here? We have tab. Okay, so do we no, so let's say peak. Peak is considered as the top. Okay, so or the top value, so we can actually call this one out something like, yeah. Okay, so since the 9 is already deleted, at this moment 8 is now the top or at the top value, so meaning when we call peak, peak will return actually 8, since 9 is already deleted from the stack. Okay, so this is how the stack algorithm does it, no? But what about we are going to create our own algorithm? Okay, of course, when we, yeah, let's go back to this one. Of course, when we don't include the what they call this one, this import statement, this would give us an error. Okay, now this time we're going to create our own ADT. Okay, and then we follow certain algorithm of the stack, and then we are going to do implementation of the basic operations of stack. Okay, so let's have here stack. So you will notice later on that under this one, it's going to be this one's I mean, for this one, you have here cause and error. I mean, the our compiler detects an error the moment we are going to create a class stack. So it's now okay, no? So this time we have created our own ADT stack. Okay, so the properties that are under stack are, of course, if we are going to implement this using an array based data structure, so array base. Okay, so this time you have here, let's say R. Okay, and then let's have something here like capacity, and then the top value. Okay, so let's now create a constructor, so or a creator. So we have here public stack, sorry, okay, and then we're going to instantiate the array. So let's say array is instantiated to new, let's say the capacity, currently the capacity for our, or when we call this default constructor, the capacity is, let's say, 5, and then we have here new, then new int array for our capacity. Okay, there you are. And then let's declare top. So you have two options right here. You either initialize the top to 0 or either -1. But in traditionally, we used to initialize top as -1. Okay, but again, you have the option to uh, use or to initialize it by a value 0. So we'll create another parameterized constructor or creator of the stack. This time, it's going to ask the capacity. So we have here capacity, and then, so this should be this that capacity equals to capacity. So and then we are going to, so this one is going to be based on, so let's have here a parang Java doc comments. So let's say this creator is going to assign or set capacity for the stack. Okay, so with the parameter capacity. Okay, and then we can actually declare like tab, or let's say bold natin. Okay, so we have here tab, is let's say so that the user have the have at least idea on the things that we actually put right here. So tap is declared as -1, okay, and then we can also like follow or okay. So let's have here creator, so default, and then we have here another creator. This is okay, parameterize construct yeah, creator or constructor. Okay, so you have two options right here, or the user has two options here. Either he or she is going to uh, instantiate the stack with the capacity by default to 5, or either he or she will assign any value or any integer value to its stack. Okay, now let's have the the first operation. No, there are two basic operations of stack: the push and the pop. So earlier I just shown you the push and pop operations. So the push operation is going to insert data or element to the stack at the top. So let's have here public void push. So you can actually use a value returning, but this time we're gonna be using a non-value returning for our void. Okay, for our push. So you have here int data. So this time we can also, I mean, you can have here a something like transformers or transformer now. So transformer this time is this is this push method is going to insert element to the stack. Okay, so the parameter is data of int capacity. Okay, data of int, let's say capacity. No, int data type. Sorry, int data type. And then yeah, so let's remove this one. And then we're gonna be starting like how is push now, what's the algorithm of push. First is, since it's -1, you'll have to increment it by 1, or you can do something like r tap plus plus is equal to data. So this time you get to store data to the or in the to the stack. Okay, so by the way, once you have already here an incrementation, you don't have to do something like in the this one here in the second statement, because you already incremented by 1 for tap. So from -1 it becomes 0. So 0, and then the r or the data will be stored in the first as the first element of our stack. Okay, so that's actually push. And then for, let's say we want to know if the stack has the elements being stored. So let's have here public string, let's say elements or display or data. It depends to you, no? So let's have and for each loop here. So let's say we have um, int val, and then going through uh, the R. However, the problem with this one is because it's for each loop, it's going to display. Yeah, let's get to see this one. So by the way, we'll have here, since this one is a value returning method with string type, so you'll have to have something like hold, and then right here you're going to hold, or we are going to hold the value, right, out of the elements from array, okay, or from our array, and then we are going to return the hold value. Okay, so let's now go back to our test stack. Okay, so you can also do something like put a a comment right here, a Java comment, so that it will be like anything, no, anything you would like to put in here in your elements or in your method elements. So at this time, since we use the default constructor or creator of a stack, our stack will have five as the size of the array. So we can now call something like st.push. So let's say 4, and then let's keep on adding. Let's say we have 6, and then we have 9, and then let's display it as we call the elements. Okay, so when we run this program, you will have here 4, 6, 9, 0, and 0. So this is the what I've told you earlier, the problem about when you use for each loop for this one. So in that, if you don't like that to happen in your program, if you don't want that one, if you don't like it, you can actually use a, okay, something like let's say a val is equal to let's make it int na lang, ri is equal to 0, I is less than 2 top, and then I plus plus. Okay, and then instead of val here, you are going to substitute it by the I. Okay, so let's go back to, so right here you have here, yeah, let's run muna, and then let me explain it to you later on. Yeah, we lack equal sign right here because we start with negative pala, not with 0 for our top. So 4, 6, and 9. So right here, what happens is that for at line 6, you push the value of 4. So when push is invoked, this in under your ADT stack here in the push, where is it here? So the data is, let's say, what was that, 4? So 4 is going to be inserted. So this is like the top here, from -1 it becomes 0 because it increments by 1. -1 plus 1 is actually 0, and then after that is basta -1, and then it becomes 0, and then here. Okay, so right here in your push, the data is 4 is going to be assigned at the array. Okay, array 0 is or will have something like 4. Okay, so in a similar manner, that's we insert, or we just inserted 6 and 9. So therefore this will be from there. Now 6 is going to be inserted, this one will be 1, and then you will have here the array 1 is going to be uh, like 6. Okay, and then this will become 2 because you insert, let's say, another data or another entry, which is 9. So this will, the top, your top now will become 2, and you will have here r 2, sorry, 2 is equal to 9. Okay, and so on and so forth. So your top now is 2. Yeah, right? Okay, your top now is actually 2. So therefore, when you get to read the elements, or when you get to call the elements, it's going to start from the first index, which is 0, until the top, which is 2. So it's going to be accessing the elements 4, 6, and 9 from our stack, and then return. Okay, so that's how push algorithm or push operation is going to be is going to process our elements inside of a stack. Okay, so now let's create another algorithm. Let's say we have here another operation, which is basic to another basic operation of stack, which is pop. So normally a pop is or must be uh, declared as a value returning type. So although it's a value returning, it is considered as transformer. Okay, so we'll copy paste this one, and then we'll have here a description on what this one all about. So this pop method is going to remove, it's going to remove, sorry, remove element from the stack. By the way, always at the top, ha. So the same with sa push. It's always at the top. Okay? And then after that, we can now, by the way, there's no parameter here, but it is, or it will return a value. Okay? Return an int type. Okay? So right here, we are going to, let's say, we will assign first the value by the array, which is coming from the top. So this time, it's our pop is going to recognize what's that value. So it should always be at the top. Okay. So since our top right here is actually 2, it's going to it is actually expecting to, or it's expected to hold value of 9. So that is right after we delete. Okay, so kasi we might lose the data 9 if we don't assign it first to a val or to a third party variable. Okay, so right here you can now say something like top minus minus. It's because every time you execute or you invoke on pop operation in the stack, the top should be decrement its value by 1. So push increment, pop decrement. Then you can have here return. We have here r. No, you can use instead have the val directly. Okay, the val would be, let's say, if you are going to call pop, so 9 is going to be assigned to val, and then before you decrement, before you, yeah, before you'll have to decrement the value because you loses the value 9. So you'll have to assign it to val. So the top now is going to be 1. So actually 9 is not deleted in your memory, but it's rather, shall we say, we call it as inaccessible. So 9, it's always there in the stack, but it's inaccessible. So physically, logically, yeah, physically, it's deleted or it's removed, but under it is actually in your RAM. Physically, it's not deleted. It's actually in inaccessible. Okay, so inaccessible because you make your tab decrement its value every time you pop. So therefore, if 2 has 9, and then you just decrement the value of top to 1, so the value that can be accessed now is now 6 instead of 9. So 9 is actually there stored in your RAM or in your memory. Okay, so let's try. So you have here, let's say you have here st.pop. Okay, and then uh, okay, after, yeah, let's display first muna, and then after that let's remove, let's call the pop method and then display the elements. Okay, oops, what happened? st.pop. Mhm, mhm. Okay, wala na to na save. So let's run the program again, and then so you have here 469 is the display of line 10, and then line 11 you have st.pop. So 9 is actually removed, so you can display something like 9 is removed, and then as you can see in the 12, at line 12 you have elements. You have here remaining 4 and 6 as the elements of your stack. So you can have something like is removed, okay, from the stack. Okay, so there, so as easy as that, push and pop. Okay, so of course if you keep on removing and removing and removing, or even pushing values to it, so since our stack has only like 5 elements, array of size 5 lang. So let's say you have 10, you have 11. So this is like 1, 2, 3, 4, 5. So more than na siya. So of course, our program would give us an error saying that it's array index out of bounds. No, that's what we called overflow. Okay, that error is what we call overflow in stack. So since we use array-based, so to avoid that or prevent that one from happening, of course, you'll have to have observers. So in your observers, okay, so in your observers, you have something like public boolean is, let's say, empty. Okay, so and then you do something like return. How do we know that the our stack is empty? If the top is equal to -1. Okay, then how do we know if our stack is full? If, okay, all right, so you have here top is equal to uh, top is equal to capacity. Now our capacity minus 1. So we'll have to minus by subtract, sorry, you will have to subtract by 1. It's because the capacity, let's say 5. So the index is starting at 0 to 4. So 0, 1, 2, 3, 4, that suffice 5 as a size. So there's no such thing as 5 index. Therefore, we'll have to subtract by 1 to make it 4, now, which is actually 5 elements. Okay, and then you can use these observers either right here in your push or either here in your desktop. But definitely, as I've told you before, when we get to create ADT, okay, make sure to not create an ADT that is going to provide everything for the user. So give a give at least a user a parang leave a business logic for the user to do, no, to so that they are also going to do their own business logic or something like uh, leave it to the user. But if you happen to actually like in ana dyan yung gusto, you can have here like if, syempre, if is full. So you can do something like if is full, you display something na error. So let's say, so stack is full. Okay, otherwise, else you are going to insert this one right here. All right, so let's see. So there you are, stack is full. It's displaying stack is full already, and then therefore you cannot push any more data to it, no? Okay, push and push. Even if you keep on pushing any value or any integer value, you are no longer allowed to do that. Okay, it will always display stack is full. Okay, so that's the first, yeah, that's the first, that's the algorithm, that's the instruction you can put, or you can give extra or additional function to your algo. Okay, let's say let's create another, let's say push. So this time, um, push S na lang, okay? So another push element. So this time you don't have anything like, okay, you don't have anything like conditions. It's just a plain, so let's erase this one. Okay, it's just a plain plus plus as we have actually declared, made it in our push earlier. So this time, instead of, let's say we don't call push, so we have push s, okay, so s naman, s, okay, of course, this will give us overflow. Ah, okay. What was that in our push S? Wala na save. Okay. So when we get to run this one, you would have here, and it will actually cause an error, overflow or array index out of bounds because we already exceeded the capacity. So in that sense, you can have something like you will be the one, or you are, if ever the user is going to implement your ADT stack, so at least he has his own way in terms of saying if it's like is full, of course, no. So if it's full, Okay, you can make that one, no, to push, no. So push natin 'yan. Okay? Otherwise, if not, then you don't push a certain, so, data or element to your stack. So that's the time you will have, okay? So let's say stack is, oh, sorry. If is full, sorry, baliktad, or pwede rin not, if not is full, so you can do something like that. If not is full, or shall we say ana na lang para the same with what we have. Oh, see, again, no, that's why I'm showing you different ways in solving that one, no. This, sorry, solving a certain or creating your own algorithm. So it might not be the case na you will always follow whatever is parang algo, but the standard way of doing it, at least we are known to that, and I mean we make known to that. Okay, so we have here, excuse me, we have here full or stack is full, and then right here. So yeah, so you'll have to make this something like uh, it has to be whenever you insert data. So let's say if is full, kasi it's already full at this moment. So dapat before that kasi wala tayo loop eh, no? So whenever you insert data to it, yeah, it's still going to actually display error, but uh, let's make it, so the next time around, let's say is full, madali na lang kasi. Okay, so you will be the one to display it. You are not able to display it because again, no, because you have here if else. I mean, diri man gud siya nag ang push, and then when you push is full already. So this one is already full. Parang if we have loop sana, wala man gud tay loop. Now, like we have a menu ba and add, let's say you keep on adding and adding and adding. The user is going to keep on adding values to it. And then the moment na the stack is going to recognize if it's full, it's going to always display stack is full now. Okay. Of course, when you have the loop, you will only have here like something like, let's say you have data there, and then you have here in data is equal to, let's say, 56. Okay, so assuming if it's parang assuming we have loops here as we keep on inserting data and inserting, and then you have every time you call the push value, or you call the push operation, this will be parang evaluated either if the stack is full or not. Okay, so these are some of the things that we can do for our stack. So I will not make this one complete because I will leave that to you. Okay, so next is I have here push. Okay, so let's make use of the push without an S. Okay, so another thing is what else? What other things we have? Let's say we want to create an observer to know the peak. Okay, so either peak, or we want to know the peak. Peak is similar to stack top, or top val. Okay, top value. Okay, you can either choose any of this one, no? So return r top. Okay, so it's just an observer that is showing that the topmost value of the top. Okay, so you can also have, if you want to know the first, of course, you'll have to use the index 0. This is for the first. Okay, so first, the first element. So stack top or top val. It depends to you, no? Whatever method you want to use for your pick. Okay, and then let's say, sir, I want to know the top value. Not the top value, but the current top. So you can do something like top. Okay, top is going to uh, okay. So, or let's say, if para di confusing, what top is that? Kasi top, this one is an attribute, this one is a method. Let's say top uh, top index na lang, top I. Okay, let's say top I, top I. But again, basically when we talk about top, it's actually going to mean it would mean top index, no? So ayan. So we have here things like we have here, we can actually call all of those now. So we have if st is full or is empty, okay, and then we have st dot peak, okay, and then you have st dot top. Top I ba yon? Oo, top I, or simply top na lang kung if you want, and then st dot first. Okay, so when we get to wait, just wait for a while. Let me go back to my tab. So, yan, wala lang na save. Let's go back to test stack. So right there, you have here is full. It's not full because we only have 3. So we have here is peak. The peak is the 20. So this one. Peak top I. So our top currently is 2. And then our first is 11. And then the elements 11, 15, 20. Then we remove 20 because that's the last, because it's because of the last in first out. So last inserted is 20, therefore it is removed from the stack. So the current elements now are 11 and 5. Okay, so yeah, I guess that's it for stack algorithm. Now for your activity, I would like you to complete this stack algorithm, and then you have a menu in it that would allow the user to choose an option either to push and to pop, and make sure to display necessary um, observers so that user has an idea of what happens to the stack already, like the elements, like what is the peak, probably if it's still empty or if it's full or whatsoever. Okay, so anyway, I'll just give an instruction for you for you to be guided on what you are going to do now. But and as an additional, you can actually insert, or you can actually assign an array or for your capacity to 20. So this time you can either set the capacity, or you can do something like what they call this one. You have here the capacity or get capacity. No, you have the option to use the capacity or get capacity. It depends again to you. So this time you just have to return the capacity. Okay, so right there, so when we call this one, or when we invoke capacity, of course it will give us the capacity, which is 20. So yeah, 20. If we don't include 20 right here, it's going to call the default size of the array, which is 5. Okay, so I guess that would be all for today. Thank you guys for listening and watching this video. Have a great day. Bye bye.